Welcome everyone to your channel, Transmission Lines Engineering TV. Maybe many of those who visit this channel wonder, well, why we haven't reached the technical topics of interest. I beg you please your patience, because soon we'll get into those topics, but I think it is necessary to talk about the importance of knowing the basic theory on transmission lines before any kind of software. Does the following phrase sound familiar to you?
Wax on, wax off. Don't forget to breathe. Very important. Wax on, wax off. Wax on, wax off.
Hey, where these cars come from?
Wax on. Detroit. Wax off. Wax on. Wax off.
Famous phrase, isn't it? But it has a deeper meaning than what it simply sounds. In order to design a transmission line, even in this computer age, in which there is software for many applications, I consider very important to know the basic theory, the concepts, variables, and technical terms used to calculate a line. A software is a tool, but it's not an automatic designer. Softwares in the market are very reliable, but it's not possible to entrust all the design and responsibility to a software, since it will be leave aside a key component, the human factor. In the case of transmission lines, I've seen how the mechanical calculation of a parameter or catenary is not requested prior to the structure's locations engineering. This calculation is the basis for the design of any transmission lines, and because of this, it is necessary to know the concepts of the change of state equation, how it works and what it really represents physically. A grounding system. In many cases, these systems are already standardized, but there are occasions where special configurations are required to solve conditions that have a very high resistivity. So, if we don't know the basic theory of the functioning of a grounding system, as what it really is, a low resistivity electrical circuit, we won't be able to make a deeper analysis when such situations arise. Or how about if you have structures with B's of suspension assemblies, and a customer concerned about the safety of their hardware assemblies request a calculation to guarantee that these assemblies will not get into compression at any given moment and might fail. Let's remember that insulators are elements designed to work at tension, but not on compression for a long time. So, how you make that calculation? Imagine this situation. You're in the field stringing a cable, and it turns out that the ambient temperature is not indicated in the second tension charts. We can perhaps extrapolate and obtain the value, but what about if someone requests us to make a calculation by hand to corroborate the veracity of our extrapolation? Another example that has happened to me: we're in the field and we realize that a structure we have to relocate from its original position, and we don't have PLS-CAD handy to verify it. Or the battery in your laptop is down and you only have the paper printouts of the plan and profile drawings. What would you do in that precise moment in which the whole construction team is on hold, costing a lot of money per hour, and you need to make an urgent decision where and how much to move the structure without compromising your vertical clearances? So, as you can imagine, not everything can be delegated the responsibility to a software. If we don't have the knowledge of the basic theory, we won't know the input for the software, no matter how good it is. In the famous movie Terminator 3, there's a phrase that I haven't said in my mind since the premiere, right on the scene where General Brewster says,
"Okay, what do we got?"
This new computer virus is a tricky bastard. It's infected half of the civilian internet as well as secondary military apps. Payroll, inventory.
Primary defense nets are still clean?
So far, the firewalls are holding up. Sir, the Pentagon has proposed that we use our AI to scan the entire infrastructure, search and destroy for any hint of the virus.
I know, Tony, but that's like going after a fly with a bazooka.
Well, once the connection's made, it should only be a matter of minutes.
In which we put everything from satellites to missile silos under the control of a single computer system.
The most intelligent system ever conceived.
I still prefer to keep humans in the loop.
and sometimes I think this is precisely what humanity is not doing. So my intention with this video is to try to generate awareness of not only limit ourselves to study how the software in the markets works, but also to invest a little time studying, like any student, investigate why and where things are coming from. Be a little more curious. Just like Steve Jobs said, stay hungry, stay foolish. Thank you for your kind visit. Don't forget to subscribe and leave me your comments and likes. So, until next video. Transmission Lines Engineering TV, training to power the world.